For the same circuit, we are going to now calculate the input resistance. So for that process, what we have to do is add some input resistance, which is variable, that is a pot. So same circuit I have modified and created here like this with some pot value. If I press capital A or small a in the keyboard, its value will increase or reduce, or I can use this slider also here. 0% indicates zero resistance. Okay. So 0% of 10k, 10% of 10k like that. If it is 100% of 10k means it is 10 kilo ohm resistor now. So initially I am placing it 0 and we can remove the CRO because it is not necessary here. Only the RMS voltage is required here. So previously also we have seen 664 millivolts. Okay. Or we can go to the previous circuit and observe once again. Here it is in transient mode. Click on interactive simulation and I will show you the value here, 664.41 millivolts. Okay, nearly 664 millivolts in the circuit 1. So same circuit is used here but with some added resistance. What we have to observe now here is to calculate the input resistance. The output must be half of this maximum value. So maximum is 664, half of this is 332 millivolts. Okay, so vary this resistor until its value goes to 332 millivolts roughly. So here I kept 40%, it is 325 millivolts, 35%, 347 millivolts. So the range is between 35 to 40% of 10k. Okay, so 3.5k to 4k is the range of input resistance. So you can take average so that we may get approximately, or we will replace this resistor. Double click on this one, replace with ordinary resistor. So between 3.5k and 4k. So let me take a resistance of 3.774k. These are abnormal values. Resistors may not be available outside for these values. So again I will simulate it. It is nearly 336. We want 332. So I will change this one to some here only you can directly change now 3.7k. So it's still increasing, so I have to reduce the resistance. So I will change it to 3.6k. And again simulate, and so 332. So the resistance is reducing means so the millivolts will is increasing. So I have to increase the resistance. I will change it to 3.8k. See, nearly we got 333. Okay, so I am stopping here. So the required input resistance here is 3.8 kilo ohms. So the circuit is having input resistance of 3.8 kilo ohms. So for observing now the output resistance, what we have to do is connect a load here and observe the same readings here without changing any input parameters. Okay, so now I may make this as 0 because we have obtained the resistance as 3.8 kilo ohms. Remember that one. Now what we have to do here is with the 664.4 again we have to observe the output resistance so that it falls half of this value. So let me connect again one variable resistor. Here we are having variable resistor with some 20k. 10k is sufficient for somewhat accurate ranges. Control R to rotate. So now initially it is 50% of the resistance, never short circuit the output. Okay, so let us test now the output voltage. It is 464. Let us try to increase this value and observe whether the output increases or reduces. 500 millivolts. So now 40% of the value. Still we have to reduce. Still we can reduce, I think, 25%. Still we can reduce. So the output resistance is from 20% to 25%. Okay, so 20% of this one is 2 kilo ohms, 25% is 2.5 kilo ohms. So between 2 kilo ohms and 2.5 kilo ohms we require this value. 25 kilo ohms is excess value, so we'll replace this with some 2.2 kilo ohms now. Replace this with a resistor instead of variable one. 2.2 kilo ohms. Now again simulate and check the value. So roughly we got 335. So if we reduce the output resistance, output will be reduced. For short circuit will give 0 voltage. So 2.1 is slightly larger. 0.15 increase. Yes, 333 we want. So 2.2 is giving larger value. Let us test it once again. So this is the value. So nearly between 2.1 and 2.2 k. So 2.15 kilo ohms. Okay, that is the output resistance. In this way, we have to calculate the output resistance and input resistance.